Next up is for anyone who wants things drawn to scale. There you go. That's it drawn to scale. I'm sorry, can you not see anything? Oops. How about now? Is that better? You can see something there, just there and there. And I'm not actually sure whether I've reached the end of the image yet. Let me just zoom out and then scroll. Right, it's not letting me scroll anymore, so I must have zoomed all the way out. Zoom in at this end. And there we go, there's something. That little speck there. Right at this end of the image. And then if I scroll across this way, somewhere there should be hello. Ah, I seem to have missed the other one of that little red dot. Let me zoom out and go back there and try again. All the way across here. Zoom in just that far, and oh, this is awkward. Oh, there it is. Look, there's a little red dot just there on the right, and it's hard to see the other ones with dust on the screen, but they should show up if I scroll the image, because the dust will stay still and they'll move. Huh. Oh, there it is. Look, there's the other one, just there. There's another little red dot. And then there's something you can see. Yeah, I knew that one would show up, and there's the other one of that pair. It's a little blue dot. I can zoom right in and you can see that it's actually... Huh. That's disappointing. Oh well. It's got two little white dots each side of it. If I scroll across here, somewhere across here, there we go. This one's even brightly lit on the left side and in shadow on the right, because I'm nice to you like that. And it has two little white dots each side of it. Now this is roughly to scale. Those are single pixel white dots, so only approximately to scale. The Earth and the Moon at perigee when it's closest to the Earth, and apogee when it's furthest from the Earth, on the left towards the Sun and on the right away from the Sun. All in plane, so if you want to, do an eclipse diagram, you can. And this is its position at perihelion, when it's nearest the Sun, and this other one out here somewhere, there we go, this one is its position at aphelion, furthest from the Sun. And if I zoom out, you can see both of those on the screen at the same time. And you can see that the difference between perihelion, over here, and aphelion, out here, is considerably greater than the radius of the Moon's diameter, radius, whichever you like, of the Moon's orbit. Because it's, it's an elliptical orbit. There is this difference between 152.1 or I think 146.09 million kilometers. It's quite a long way. And if I leave it at that zoom where the Earth, even the Moon shows up, hoping even the Moon shows up on screen. Here's your aphelion, here's your perihelion, and just scroll across sideways. Again, and again. There we go, a pair of little yellow dots. Those little yellow dots are aphelion on the right, perihelion on the left, for Venus. And again, if I scroll in, yep, they're drawn to scale and they're sunlit on the left and shaded on the right. And And then just ooh, there's something. There's something right there. That's just 4 pixels. Just a 2 pixel diameter there. Again, sunlit on the left, shadowed on the right. That's Mercury, which is kind of greyish, apparently. And either Mercury has a very elliptical orbit, or I missed the aphelion for Mercury. There we go, there's the sun. There's the sun to scale. Oh, I'm sorry, you can't see that, can you? How very annoying. There is the sun to scale, at the left side of the screen. And that thing on the right is the mouse cursor. This bit. And if I zoom out to there, we've got the sun on the left, the mouse cursor in the middle, and oh, found Venus again. That's Venus, perihelion, aphelion. Just there and there, and just here. And there's the sun, to scale, with the size of Venus, which was, I think it was somewhere just there. And so Earth should be somewhere here-ish. Maybe. That's something. No, that's red. That's Mars at perihelion. I hope so that's big enough for me to see it on the screen so I can see Earth when it appears on screen. Of course, Earth is bigger than Mars, so it's a little... There we go. There we go. Got Earth at perihelion, Earth at aphelion. There and there. Or... there and there right now. And there's the sun to scale with, you know, that's Venus again. There's the sun to scale, and Earth is, there we go. I've got an Earth. Not sure, oh yeah. Perihelion, aphelion out here. And that scale is why your diagrams of the angles of sunlight during a solar or lunar eclipse aren't drawn to scale. Because 1 pixel for the entire moon isn't anything like big enough. If you want it drawing to scale, you have to draw, well, if you want something that will show you why you get a 70-mile total eclipse, or no total eclipse, or an annular solar eclipse, you need a resolution that's preferably no more than 50 kilometers to the pixel. And 50 kilometers to the pixel is 1/500th of this, I think. Well, easy way to answer that. Here is a calculator where you can see it. Yes. And 6356752. Turn on numlock. 6356752 times 2 is 12,713,504 meters from pole to pole, straight through the centre. Current scale is 2.5 million meters, 2,500 kilometers per pixel. Let's just divide by 1,000 to get a number of kilometers. 2,500 kilometers per pixel. 50. You would need to make this image 50 times as large to get 50 kilometers to the pixel in order to accurately show those moon shadows. This is why you don't get the whole distance, the full size of the sun, and the whole distance from the sun to the moon and the moon to the earth and the size of the moon and the size of the Earth all drawn at the same scale in the same picture. It's because it would look like this, but 50 times bigger.